We wrote our timer interrupt routine that's going to multiplex the displays. So let's load it up and try it out. So you can see we still have the old program loaded. So we're living dangerously. We're going to try it out right now. So right. Says it loaded successfully. So what it's supposed to do is it's supposed to just count through the display. And I also programmed in the buttons. The right button should increase the rate of the counting, and the left button should decrease the rate of the counting, maybe even make it go backwards. So let's see if it works. Well, it seems to count awful funny, doesn't it? So, doesn't seem to be working correctly, but the good news perhaps is that we actually see real numbers displayed in the display. So part of it is working correctly in that we receive actual data. So let's think about it and come back a little later. Alright, we took out the part, we just commented out the part where the switches do anything. So if that's the part that's failing, then it won't matter anymore. Kind of a divide and conquer strategy. So let's load up a new one. Alright, give it a shot. Well, that looks better. Here comes our helper again. Come on, get your butt out of the camera. So there's something wrong with the way we're reading the switches. Either the time constants are too fast and it always reads wrong, or something along those lines. So we'll have to look at that. So we made some changes to fix the erroneous decimal points, and we put a command in to charge the B port high before we had tri-stated it. So hopefully that will allow the switches to be read correctly, I guess is what I'm trying to say. We'll see if it works. And so it doesn't work. Alright, starting again. I had an idea that since these pins are multiplexed into different functions, like we have the data in the clock, and it also goes to the LED, and also goes to the switches, although one of the switch is on RB5 instead of RB6. But anyway, I'm going to disconnect those while it's running. So let's reset it. Alright, so that's it. The PIC kit 2 was loading these signals down, so it didn't work correctly. So anyway, this switch is supposed to make it count up faster. I think it's working. This switch is supposed to make it count slower. And it stopped counting, and it should start counting backwards. So it looks like there's wasn't really anything wrong with the program. It was we had that hooked up and it was loading the circuit down. So I'm glad we found that before we spent too much time debugging the program, since it wasn't a problem in the program. I've been working on the circuit. You can see that the switches, this is RB7. The switches have a 100K pull up to 5 volts, and there's a 2.2K pull down when you press the switch. And the other switch is on not RB6 but RB5. Then on RB6 we have this circuit here, which is, it detects the AC coming in. There's a half-wave rectifier, a cap, and a very high resistor that goes down to the RB6 pin. And that's a digital only pin, so really you get like a go no go test there for AC. Now I can move this down to here. There's also a circuit that you can check the voltage on the battery. So you have the voltage on the battery, goes through a fairly low value resistor. So transistor is a switch, and a 51 ohm resistor as a load, and that goes to an analog input. And the transistor is switched with a an output. So I did a quick calculation with these resistor values, and I think that probably draws about 50 milliamps out of the battery. So you wouldn't want to do that continuously. You just want to switch that on and check the battery and then switch it off, so you don't wear the battery down really quick. What I'm thinking is that this will make this an AC line voltage monitor. So it will display the AC line voltage, and then if there's an anomaly on the line voltage, like a too high voltage or too low, power dropout or whatever, it can detect that and then store it in the EEPROM, and then you recall that. You can read that out later, is the idea. Store the event in an EEPROM and have some facility to read it out and display it. And what I'm thinking that I'll do is I'll cut the etch on this circuit over to VBAT. Then I'll wire that circuit up to this one up here. So we'll actually be checking the AC voltage with an analog pin rather than a digital pin. And I should be able to read the voltage and display it on the LED. So I'm going to work on that. Probably going to take a while to get something working.